Okay, we got the proper form. I need to identify the A and the B. I'm going to talk you through this one. Certainly the formulas need to be known. Um, the A is 18, and the B is going to be minus 6. You're going to plug it into the formulas, right? The formula for H, it's written down for you. You plug it in, and I'll do the arithmetic just to verify that this is correct. So I'm just plugging in the B is minus 6 and the A is 18. So it looks fairly simple. Let me put this over here. This will be equal to cube root. Looks pretty simple, right? So what do you get there? I guess you would get 3 minus, not minus, I'm sorry, plus the square root. Well, it's 36 over 4, which is 9. And I know that looks difficult, but it's really not as bad as it looks. 18 cubed is 18, 18, 18, and 27 is 3 times 3 times 3. So this gives you 6 cubed, or that would be 216, right? Okay, let me write that down. I'm going to keep going. I'm going to simplify this. The cube root, 9 plus the square root of 225, which is 15. And I'm sorry, I said 9, it's 3. Get my eraser out. So I got the cube root of 18. I'm going to do this one over here. It's very similar, by the way. And what do you see over there? Well, you're still going to get 3, but now you get minus 15. Right, we just did that computation, by the way. So we're going to give you the cube root of minus 12. I'm going to pull out a minus 1, so it's really minus the cube root of 12. All right, not much I can do about those numbers. What I want to claim is I need to know how to get the roots now. x1, x2, x3, there's 3 roots. The complex pairs, the complex solutions will occur in conjugate pair. So the first one, fairly simple. All I do is add h and k. That's all I did, added them together. Now the other ones, what am I doing? I'm still adding h and k together, but I'm taking their opposite. So really what I'm taking the opposite of what's above it, which is the cube root of 12 minus the cube root of 18, that's the opposite, divided by 2, plus h minus k. Well, that's pretty simple. H minus k is going to be the cube root of 18, and then k is going to be minus, so it's going to be minus and minus plus, so we get this over here. I'm just putting in the same order, 12 and 18. Divided by 2, root 3i. And again, these are going to occur in conjugate pairs, all right? These two are conjugate pair. A plus bi, a minus bi. It's remarkable. That's true for all real coefficient polynomials. Their roots, if complex, will occur in conjugate pair, all right? So I think we finished it up. There's only 2 problems there. I realize you may need to reach out to me because you feel like I wrote something down that's incorrect. And my name is Ron Bannon. Let me get rid of that. Let me highlight it for you, though. And my email address, Bannon, B as in boy, the @ symbol, NNON.US. By the way, if you think the cubic is difficult, what you should do is there's also a formula for a 4th degree polynomial. And you may want to go to the Wikipedia to look how bad that is. It's ridiculously difficult to write down. By the way, it's even ridiculously difficult to type up. These aren't too bad, though, by the way, to type up and do. But this is no longer taught, at least to my knowledge, in any public curriculum in the United States. Certainly, you may go to other places of the world where it's still taught. But I think the main reason it's not taught, it's really kind of almost like a rote learning experience for most people. And it's really not productive, all right? But it is there. I imagine if you were writing numerical algorithms, that this would be one algorithm that you would need to know for solving a cubic problem. And there's tons of algorithms to know, all right, in mathematics. Some are pretty difficult to derive. Some are easier, like for example, the quadratic formula, as you may recall, when you did the derivation of this over here, it was a rather simple process. Really simple to get that, all right? What do we do with that? We complete the square basically. It turned out to be a pretty simple problem to do, get a formula for it. That's why it's widely taught and it's widely known. Thank you.